Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about vector algebra basics. So these basics are going to help you in understanding our next classes where we are going to discuss linear algebra. So this is our first class in linear algebra. These basics are very important. And these basics we already covered in our +1, +2 mathematics. Just we want to refresh the concept. So coming to vector algebra basics, a vector, suppose say 2, 3 is a vector in two-dimensional space. Means it is having x-axis, see this is x-axis and y-axis. This is a two-dimensional plane. In this plane, a vector is represented using 2, 3, two values. One value represents the value that moves towards x-axis. The second value represents the value that moves towards y-axis. Means it is moving 2 units towards x-axis and 3 units towards y-axis. So a vector is shown in, graphically it is shown like this. So this yellow line, this is what we call it as 2, 3 vector. Means it moved 2 units towards x-axis and 3 units above towards y-axis. So that's why this yellow line, this line 2, 3 is a vector. See, it started from 0, 0 means from origin and it moved towards 2, 3. So a vector is having a direction. It is moving this side. It is having a direction. And similarly, a vector is having a magnitude. The length of this vector, we call it as magnitude. So vector is having two values, length and direction, in which direction it is moving. So what's the length of this vector? From the Pythagoras theorem, we can say this, the length of this vector can be represented as if you take 2 points, 0, 0 and 2, 3 is a point, how you find the distance of this value? Square root of 2 minus 0 whole square plus 3 minus 0 whole square. Similarly, square root of 2 square plus 3 square, which is square root of 13. This is the magnitude of the vector 2, 3. So most of the times vectors are represented like this in the row way. But in linear algebra, we are going to represent vectors in the second way, which is in the column order. 2, 3 can be represented like this, 2, 3. So from now onwards, we will use this notation, vectors represented in the column direction. Similarly, the next vector is 1, 2. Means it is moving 1 unit towards x-axis and 2 units towards y-axis. So that's why the direction changes and the length changes. Each vector is having its own direction. This is the point you need to understand. Similarly, the next vector, minus 1, 2. So it is moving minus 1 unit towards the negative side. So negative side of the x-axis. And 2 units towards the positive side of y-axis, means above. So minus 1, 2 is a vector that represents like this. It is having length and it is having a direction. It is moving this direction. Similarly, a vector in a three-dimensional space can be represented like this. See, x-axis, y-axis and z-axis. See, for better understanding, z-axis will be like this. This board is a plane, x-axis, y-axis and this is z-axis. So 2, 3, 4 is a vector in a three-dimensional space. And this can be represented like this, 2 units towards x-axis and 3 units towards y-axis and 4 units towards z-axis. So this vector should be like this, in this direction. See, the second hand, this hand we call it as a vector. It is moving like this. Here it will stop. This is how a vector in a three-dimensional space can be represented. The length of the vector is a square root of 2 square plus 3 square plus 4 square. This is what we call it as length of the vector, means magnitude of that vector. And it is moving in this direction. See, from here onwards, it is moving in the space. 3-dimensional means space. Similarly, a vector is in a 4-dimensional space can be represented using 4 values, 2, 3, 4, 5. So we cannot show 4-dimensional space. You assume it as one more thing, x-axis, y-axis and z-axis and w-axis. In the 4-dimensional space, our vectors will be represented like this. So this is the graphical intuition you need to understand about vector, and you need to understand few algebraic operations that we apply on vectors. So a vector is multiplied by a scalar. Scalar means some value. So 2, 3 is a vector. This is multiplied by 2. This is represented like this. Scalar multiplied by vector, that is equal to 2 2s 4, 2 3 6. 4, 6 is the new vector after multiplying with scalar. And the graphical intuition, what happens when you multiply with scalar, that is the point you need to understand. 2 units towards x-axis, 3 units towards y-axis. See this pink line, we call it as the 2, 3 vector. When it is multiplied by a scalar, the 2 value increases to 4. The 3 value increases to 6. Means 4 units towards x-axis, 6 units towards y-axis, and the vector is this 4, 6. See, the point you need to understand, when it is multiplied by scalar, the direction does not change. The length of the vector increasing, but the direction, it is moving in the same direction, means it is going in this direction, in the same line, in the same direction it is going. Direction has not changed, but what changed here? The length of the vector changes. Suppose if you multiply 2, 3 using a minus 10, your vector will be in this way, it will go. Minus 10 means minus 10 multiplied by 2, minus 20, minus 10 multiplied by 3, minus 30. So the vector moves in the same direction but opposite to this. See, this, it in the same direction it will go. Towards this coordinate. This is what happens when you multiply a vector with a scalar. Its direction won't change, but the length of the vector changes. Similarly, adding two vectors, this is the concept. So 2, 3 is a vector and minus 4, 2 is a vector. If you want to add these two vectors, 2 plus minus 4, which is minus 2. 3 plus 2, which is 5. The new vector which we got after adding two vectors is minus 2, 5. The graphical representation is very, very important for our next classes. So what happens when we add two vectors? 2, 3 is a vector. This is the vector because 2 units towards x-axis and 3 units towards y-axis. Minus 4, 2 is a vector. This is 4 units towards the negative side of the vector x-axis and 2 units towards the positive side of the y-axis. So this is the minus 4, 2. If you add it, see graphically, 2, 3, this 4, 2 exactly move in this way to the end of the first vector. Means 4, 2, if you move to the end of the first vector, see here, 2, 3, 4, 2. So it moved to the first vector showing that 2, 3 means 2 units towards x-axis, and from here onwards minus 4 units towards x-axis, means again it is moving back. Adding means that is what happens. So that's why this minus 4, 2 exactly bring to 2, 3, tip of the 2, 3. So if you bring like this here, this is minus 4, 2. This pink line we call it as minus 4, 2. This green line it is 2, 3. So it moved towards x-axis 2 units. Again it moved back minus 4 units, means where it will stop? Minus 2. 2 again back minus 4 units, means minus 2 it will stop. Similarly, this vector moved 3 units above. From here onwards, this vector, this second vector moved 2 units above. 3 plus 2, 5. So totally it moved 5 units towards y-axis. So our new vector is minus 2 comma 5. This blue line we call it as the minus 2 comma 5. This is what happens when we add two vectors. Graphical intuition is important for our next classes. Hope you understand this basic algebra which we are going to use in our vector algebra. Hope you understand this class. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.